Guys, welcome to my YouTube channel. Today we will save ADC values to SD card for 5 seconds. What we need to have: STM32F4 Discovery board, SD card reader, potentiometer. If you don't have potentiometer, you can connect ADC pin to 3 volts of board, of course jumpers, and sections that will cover ADC with interrupt, SD card with DMA. Okay. Let's open CubeMX. In help section, you can click about. As you can see, version is 4.21. Make sure the program version is 4.21 because there may be problems with future versions. Okay. Click new project. Okay, MCU selector. We'll type STM32F407 VG. This one. Click on it. We'll do some configuration on CubeMX. Let's start in peripheral settings and click RTC values. Click RCC. We'll use external oscillator, crystal ceramic resonator. Just clicking. Okay. And system, you can use serial wire, or you don't have to enable this one. It detects. And then we'll use STIO, of course. STIO in 1 bit. You can select 4 bit, but my SD card reader is 1 bit. Okay, as you can see, the pins of a SD card reader, this one, PD2, PC12, PC8. I'll show this later. Okay, and just click FATFS in middleware section and just enable SD card. And let's go and we will enable ADC1. Let's enable ADC1 in channel 1. Okay, and in STM32F4 board has 4 LEDs, and in PD12, 13, 14, and 15. Let's enable these ones for output. GPIO output. Okay, and let's go clock configuration. We'll use this one is the crystal resonator. You can enter 8, or select 8, and we will use PLL clock and frequency 168. Let's enter, and APB to prescaler to 16. Why I did this? Let's open first. And this ADC1 connects to PCIK2 clock line, so I set to 10.5 MHz, as you can see, and we will set ADC settings to prescaler 8, 480 clock and 12 bits, of course. And these calculations gives 2651 sample per second. First, 10.5 MHz divided by 8. Okay, then 12 bits plus 3 bits is coming somewhere, but I don't remember. And you are just summing these 480 and 15 to just multiplying, and you are taking 1 over result gives this one. You can say first, but in ADC the sample per second is generally used. Okay, let's go configuration. Let's do first ADC1 configuration. Click on it. Modes, independent modes, clock prescaler, as I mentioned, 8. Resolution, as you can see, 12 bits gives 15 ADC clock cycles, 3 clock cycle coming from somewhere, but I don't remember. These are disabled. We will enable conversion mode by yourself. Okay, and rank, click rank, and sample time 480 cycles. Okay, and click MVIC settings. ADC1, ADC2 and ADC3 global interrupts enable. Okay, we'll use ADC with interrupt. Okay, apply. Okay, and then let's go STIO. STIO is used to write or read SD card, and its parameter settings, you don't have to change this one. You are just enable STIO global interrupt. Okay, and we use with DMA. Okay, click DMA settings, add, select STIO-TX. Okay, and add again. I will select STIO-RX, apply. Okay, in the path you can increase maximum sector size to 4000. Okay, okay, that's it. I guess everything is done in CubeMX. Okay, let's generate code. Let's give a project name. Okay, I use Turkish Studio, and you can increase minimum size and minimum text size. There might be a problem because let's give 2000, this one 4000, and click OK. It's generating user source code. I'll stop this video and I will continue. And let's start project. Click on it and click search and double click main. It's our main code. I will read this part. Okay, now first we need to change some parts on BSP driver STC. Just click this one and you will change. Okay, this one I will upload these codes. We'll change BSP SC read blocks DMA. BSP SC read blocks DMA. This BSP read blocks, we will change just DMA. Okay, BSP read blocks DMA, Control V, and we will copy BSP SC write blocks DMA. Just copy it and write blocks, Control V. Okay, and click OK. And in the middlewares, pathways, no, on just drivers. Okay, it's not this one. Middlewares, search, and middlewares, third party pathways, SRC, and drivers. Click SD disk IOC. I will change these ones. The result SC read. Okay, let's find the result SC read. The result SC read, or this one. Just Control V and copy the result SC write. Okay, the result SC write. Control V. Just let's build. Is there any mistake? Building project. Okay, I will upload these codes also. Is there any mistake? No. Okay, Okay, there is no mistake. This is unused variable. No need to worry about that. It's unused variable. Okay, let's start this one. Start from here. User code begin. Okay. We will use FATFS, so we need to create these values. Let's say my file. Okay. The file is my FATFS my. Let's give a FATFS and file my file. I will talk about these variables. Okay, don't worry. uint my bytes. Okay, f results parameter. This gives results and the status, and this one is SSDs. Okay, and before go that, we are using ADC with interrupt, so we need to look at a function, and you can see from drivers, all drivers search, or just looking search. Okay, HAL ADC interrupt. Is there any HAL ADC or okay, sorry. And conversion complete callback. Yes, this one. This function, we use this function. Regular conversion complete callback in non-blocking mode. Okay, just copy this one. Conversion callback and paste it. When ADC interrupt occurs, this function will be applied. Okay, this one. And okay, here we will have a buffer. Let's write uint32T ADC results. Okay, and the array length will be, as you can see, 13,255. Okay, and let's give a new 0, and okay, it's converging object. Okay, here if, let's write I smaller than 13,255. Okay, ADC result I, and this, we use this function ADC control space get value, and the pointer is HADC1, I guess. Let's look. Yes. Okay, and then we'll increase I. Okay, and we didn't enable continuous conversion mode, so we need to start interrupt again. HAL ADC start. Okay, sorry, start IT and HADC1. Okay, else this flag is 1 and HALADC stop IT sub interrupt. Okay, and pointer is H1. Okay, what does it mean? Each ADC interrupt occurs, it comes here, I smaller than this value, it will get to and write to ADC result 0 and increase I, okay, and start interrupt, and it will come again here, okay, and I is 1, goes like that until 13,244, okay. This is, we can say, buffer, of course. And if I reach this one, it goes to else and flag 1 and stop interrupt, okay. Okay, I have phone call, sorry. Okay, let's go main function. This is main function. In while section, let's start. Let's say whole GPIO, okay, write pin, and GPIO D, we will enable lates, and GPIO pin, let's say GPIO pin 13. Or if you don't know the parameters, you can click control and click this one. As you can see, it shows parameters, and this pins selected with, let's right click your pin set, ledon, okay, and here sorry, and if flag is 1, okay, if flag is 1, we will have, we need to initialize our SD card disk in a initialize, okay, in 0, okay, we initialize, and results is, we are just mounting mount, and as you can see, parameters FATFS with of course with pointer. So end section, we describe in the beginning. So my FATFS, okay, and what is path, okay, and the path is SD path, okay, SD path and 1, and let's char my file name, okay, I don't know, let's write the ADC, please write upper letter, ADC val dot txt, okay, and result fopen, open, as you can see, fill my file, and constant teacher path, and this is the my file name, actually my file name, and byte mode, okay, you can click on it to see more clear, fopen, or let's write it fa, as you can see, create new, and fi write, okay, and then you'll use for loop for integer, let's say counter is 0 until counter smaller than Each value 13,255 and counter, increase counter. Okay. Then I'll pass this part a little bit fast, so I will explain all of them in my website dogankayadelen.com.tr dogankayadelen.com.tr. Okay, and this one is ADC result, counter. Okay, this is a counter 1000. Okay, or let's try 0 and try 1. ADC result and counter over 100 and 110. Okay, and let's try 2. ADC result, counter divided by 10 and 110, I guess. Okay, and try 3, and this is just ADC result, counter 100%. Okay, try 0, 1, 2, and sorry, we will let's find the try. Okay, char, and we use try 4 and char, and let's write path 4. Okay, and for now it's enough. Sorry. Okay, actually these are for selecting bits. Okay, and we are just adding 48, and let's write path 0, try 0 plus, we are just adding 48 to convert ASCII. Actually, let's copy 1, 2, 3, and 0, 1, okay, 0, 1, 2, 3, 1, 2, 3 to convert that ASCII. Okay, and result is we are just using FLSeq. Okay, and as you can see, my file and the words my file. Sorry, first we need to let's open it. If open my file and my file name, and if I write and result, do we need to open it again? We open here, we don't have to open it. Okay, please, sorry, I'll change to FLSeq and my file, and this let's look the words UOFC, and let's start my file dot f size. Okay, because the words, and results f write my file and buffer and size, and as you can see unit. Okay, let's click on it. Number of bytes to write, size of size of buffer, size of buffer, and uh, my bytes. Okay, my bytes. Write my bytes. Okay, here. Result this for E4 and result. Now we can close our file and flag is 0. Let's write how GPIO write pin GPIO D GPIO pin, let's say 12, and states, let's write pin set. Okay, serial missing point, no, let's build the mistake. Okay, click on layout. Why? Okay, let's write integer flag is 0 actually first. Okay, there is no mistake. And now I will stop the video and I will show how to connect SD card reader and potentiometer. I connect all connections. As you can see here, we have SD card reader. It has a 3-volt pin, CS, MOSI, clock, MISO and ground pins. You don't need to connect CS pin. As you can see, it's empty. Okay, and for connections, for MOSI is PD2, clock is connected to PC12, MISO is connected to PC8, and the other one is ground and 3-volt. And for the potentiometer, the gray one is connected to ADC, which is PA1, and purple one is connected to 3-volt, and white one is connected to ground. Okay, so micro SD cards, and I'm just connect to micro SD card reader. Okay, I just connect it. And here, by the way, I missed a line. Okay, we have to add HAL AD start interrupt here in the main section. Okay, I put a toggle here and I'm just debugging. And I'm just clicking resume. Okay, I click and I can change my potentiometer, as you can see here. And as you can see, it's done, flag is 0, and it closed the file. Okay, let's unplug micro SD cards and look. Okay, I put to my adapter. Let's look. Okay, as you can see, this one txt, as you can see, it's here. The ADC values are saved. We change potentiometer values, so these values is changed for 5 seconds. As you can see, 53,021, and in here 3 over each one is 4 5, just divide to 4. As you can see, 13,255. Thanks for your attention. See you in next video.